Okay, problem one. We have a cube root graph, and we're going to graph it. So the first thing we need to do is find the key point, and we do that by asking the question, what number minus 2 would equal 0? Positive 2. And then our back number is the y value of our key point. So for the cube roots, I recommend that we figure out how to create the cube root of 1 and the cube root of 8 to help us find some other key points. So first I'm going to go ahead and graph 2, 1. All right, so now to create the cube root of 1, I ask the question, what number minus 2 would equal 1? And that is going to be 3. So I'm going to have the cube root of 1 plus 1. The cube root of 1 is 1 plus 1, that's 2. So our coordinate, we plugged a 3 into the x, so that's the x part of the point, and then we get the answer of 2, which is the y. So we'll be at 3, 2. Now remember, we're going to mirror some of these points for the cube roots. So therefore, if we have a point that is to the right 1 and up 1, then we're going to have one that is left 1 and down 1. These two red points should always be diagonal of each other. It doesn't matter if they're going this way or this way. They should always be diagonal of each other. Okay, now we got to go ahead and do the cube root of 8. So we ask ourselves, what number minus 2 is equal to 8? That would be 10 minus 2 is equal to 8. That's going to give us the cube root of 8. The cube root of 8 is 2 plus 1 is going to give us 3. So we plugged a 10 in, so that's the x, and we got 3 as y. So our point is 10, 3. Once again, we're going to mirror this point. So if starting from my center point, if I count up 1, 2, and then I count 2, 4, 6, 8. So I went up 2 and right 8. So I'm going to do the opposite. I'm going to go down 2 and left 8. 2, 4, 6, 8. And so now that I have my curve, I can just draw it. So now we can go ahead and answer some more of these key features below. It does ask for the x-intercept, and that means the place where the line touches the x-axis. It's right there at 1, 0. And then it's asking for end behavior. Left side end behavior is talking about what is going on this side of the graph. So as x goes towards negative infinity, the y value is heading towards, we can see it's slowly going downwards, so that means it's going to head towards negative infinity. Okay. Right side end behavior, that means we are looking at this side, and as x heads towards positive infinity, the y value is going towards, you can see this thing is above the x-axis. If we drew more of this, you would eventually see it to go up higher and higher and higher and higher. It's heading towards positive infinity. Problem 2, another cube root graph. So this time it's a little bit more complicated. We have a number in front that we gotta make sure that we're keeping track of when we're doing our calculations, but the beginning is always the same. We want to find the key point. So we ask the question, what number minus 2 would equal 0? Positive 2. And then our back number is a 3. So this is where our key point comes from. So now that we have that, we want to recreate the cube root of 1 and the cube root of 8. So we ask the question, what number minus 2 is equal to 1? That would be a 3. So we would have the cube root of 1, 3 take away 2 is 1. The cube root of 1 is 1. Negative 3 times 1 is negative 3. and negative 3 plus 3 is 0. Once again, we plugged in a 3 in for the x, and then we got the answer of 0, so that's our y. So I'm going to go ahead, I'm going to plot my key point 2, 3. And now I'm going to plot my first point 3, 0. Now I'm going to go ahead and mirror that. So if I count from my key point down to the red one, it's down 3 and right 1. So I'm going to do the opposite, up 3 and left 1. Once again, those 2 points should always be diagonal of each other. Now we're going to do the cube root of 8. So we have to ask ourselves what number minus 2 is equal to 8. That would be 10. The cube root of 8 is 2. Negative 3 times 2 is negative 6. Negative 6 plus 3 is negative 3. And once again, we plugged in a 10, so that's our x. We got a negative 3, that's our y. So we're at 10, negative 3. Once again, we are going to go ahead and mirror that point on the other side by simply counting from the center point to our green point. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. We're going to go in the opposite direction, so now we're going to go up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And now I can draw the curve. And now we can go ahead and answer some of these key features at the bottom. The x-intercept we can see touches the x-axis at 3, 0. Positive interval. So positive interval, a little reminder, is the section of the graph that is above the x-axis. And the negative interval is where the graph is below the x-axis. So there's a lot of different ways to write it, but the way I always write it in class is x slash. I think to myself, what is the smallest x for this problem? Well, I have the arrow heading towards negative infinity. So my smallest x is negative infinity, less than x, which is less than. And it stops right here. This is the section where the graph switches from being positive to negative. And so that's happening right there at 3. And just remember, we don't do an equal to on the 3 because that 3 is neutral because it's on the x-axis. It's not part of the positive part of the function or the negative part of the function. And then we're going to go ahead and do the negative interval. So once again, we're going to write it x slash. Now our smallest value for x for the negative interval is going to be that 3 less than x, which is less than. Now this graph is heading this way forever using all these positive x's forever and ever and ever. So we're using positive infinity. Okay, problem 3, solve and check for extraneous solutions. So we always want to make sure our radical is by itself before we get rid of it. And it is. So we have nothing in front of it, we have nothing behind it before the equal sign. So now we want to get rid of the radical. It has an index of a 3, so we're going to use an exponent of a 3 to cancel it out because that means they're opposites of each other. And opposites cancel. So now we have 5x plus 3 equals 7 to the third power is 343. We want to solve for x. The radical's now gone, so now we can move this 3 over to the other side. So we're going to have 5x equals 340. Then we can divide both sides by 5. And we get 68. So x equals 68. But the question is that a solution or is that an extraneous solution? To figure out which one it is, we need to plug it back in and check our answers. You need to do this for all of the solving radical equation problems on your test. Every single one. Do not assume. So I'm going to have cube root 5, the x is now going to be the 68, plus 3 equals 7. So I'm going to see if the left side of the equal sign is going to end up being the number 7. So 5 times 68 is 340. Now I have 340 plus 3. That's going to give me 343. And then I'm going to go to my calculator and I'm going to cube root that. Once again, the way you type that into the calculators that you have in class is going to be 3. You're going to hit the number 3. You're going to hit the second button. Then you're going to hit the caret button. And you're going to see this little symbol like this on your calculator. Just type in 343, close your parentheses, hit enter, and it's going to tell you the number 7, which means 7 is 7. That makes sense. Therefore, x equals 68 is a solution, and there isn't an extraneous, which means you leave that blank, write nothing there. Okay, problem 4, another solve and check for an extraneous. So this time, it's going to be a little tougher than last. We have x equals the square root of 18 plus 3x. Once again, before we can get rid of the radical has to be by itself, and it is. There's nothing in front of the square root, and there's nothing behind it on the right side of the equal sign. But you have to remember that when you see this radical sign, if there's not a little index number there, it's really an invisible 2, which means to get rid of it, I need to square both sides. So these will cancel each other out. So we have 18 plus 3x, and now we have x squared on the left side. Well, we have an x squared and an x, which means we need to move everything to one side so we can factor. Now, in this case, since the x squared is on the left side of the equal sign, we want to move everything over there. So I'm going to minus the 3x. I'm going to minus the 18. So I will end up with x squared minus 3x minus 18 equals 0. Now I have a trinomial, which means if I want to know what x is, I'm going to need to factor. So I have x squared here, I have negative 18 here, negative 3x here. X squared times negative 18 is negative 18x squared. I need to figure out two numbers that multiply to be negative 18x squared, and the same two numbers are going to add to be negative 3x. So our combination is going to be negative 6x and a positive 3x. So negative 6x, 3x. All right. So x times x will give us x squared. X times 3 is 3x, and x times negative 6 is negative 6x. So now we have x minus 3 and x plus 3 equals 0. Zero product property means we're going to set each one of these factors equal to 0. Then we're going to solve. So I'm going to add 6 over. So x equals 6. I'm going to minus 3 over. So x equals negative 3. But we are not done. These two could both be solutions. They could both be extraneous. Or only one could be a solution and one be an extraneous. We don't know until we check. So to check, we're going to take the 6. We're going to do that one first. We're going to plug it into the original equation. And we're going to see if the left and right side is the same. So I'm going to do what's inside the radical first. So 3 times 6 is 18. And 18 plus 18 is 36. The square root of 36 is 6. And 6 is 6. That makes sense. X equals 6 is going to be a solution. We just need to see if the same thing is true about negative 3. So we have negative 3 equals the square root of 18 plus 3 times negative 3. That's going to give us 18 minus 9. 18 take away 9 is 9. The square root of 9 is positive 3. So negative 3 equals 3. That doesn't make any sense. So that means x equals negative 3 is the extraneous. All right, problem number 5. Solve and check for extraneous solutions again. This is just like the last problem. I know this one can be a bit tough for people, so I want to put some extra ones on the study guide for this. All right, so once again, we have an invisible 2 for the index, which means we are going to use the square to remove the radical. So we are now down to negative 48 plus 14x equals x squared. X squared is on the right side this time, and we want to move everything over to where that x squared is. So I'm going to minus the 14x. I'm going to add the 48. So I'm going to have x squared minus 48 plus 48. Those all cancel out. It's going to equal 0 because we are going to be solving for x. So we need to factor. We have x squared. We have 48 negative 14x. And those are going to multiply together to make 48x squared. Then we got to figure out two numbers that multiply to be the 48x squared, and those same two numbers add to be negative 14x. I think it's negative 6 and negative 8. Yes, so negative 6x, negative 8x will be our two numbers. So negative 6x, negative 8x. So x times x gives us the x squared. X times negative 8 is the negative 8x. X times negative 6 is the negative 6x. So we have x minus 6 and x minus 8. From there, x minus 6 equals 0. X minus 8 equals 0. We're going to add the 6 over to get x equals 6. We're going to add the 8 over to get x equals 8. But once again, we have to check our answers. So let's do that. I'm going to start by checking the 6 first. So I have the square root of negative 48 plus 14 times 6 equals 6. So 14 times 6 is 84. So I have negative 48 plus 84 equals 6. And therefore, with that calculation, we get the square root of 36. And the square root of 36 is 6. So that makes sense. So x equals 6 is a solution. I'm going to go ahead and check for 8 this time. So I have the negative 48 plus 14 times 8 equals 8. Once again, I'm just replacing all the x's with 8 because I'm checking 8. So 14 times 8 is 112. All right, and so minus the 48, we get the square root of 64. And the square root of 64 is 8. Hey, another solution. 8 equals 8. Therefore, x equals 8 is another solution, and there are no extraneous, so we just leave that blank. Problem 6. We have this square root graph this time. Use the square root because we don't have an index there, which means it's an invisible 2. And they want us to graph it and then state some key features. So we start off by finding the key point first, just like always. And we do that by asking the question, what number plus 4 is equal to 0? Negative 4. The back number is 2, so that's the y part of the key point. And I'm going to plot that. So negative 4, comma 2. Now, very similar to the cube roots, we do need to create certain square roots to make our life easier, like the square root of 1 and the square root of 4. And you could even do the square root of 9 if you like. Now, this time, there is no mirroring points. A square root graph is simply a point with a line going in one direction. It could be like this, or it can be like that. It goes in no other direction. These are the only directions you can go on the test. So, we need to figure out what number plus 4 would get us a 1. Well, negative 3 plus 4 equals 1. That's going to give us the square root of 1. Notice how I'm writing this minus sign in front, because it's right there in the problem. Don't forget it as you write your work. The square root of 1 is 1. Well, negative times a 1 is negative 1. So negative 1 plus 2 is 1. And so I plugged a negative 3 in for the x. I got a 1 for the y. And so I'm going to plot that point. Once again, there's no mirroring points here. Square roots are just these curves you see here in purple. Okay, now we want to create a square root of 4. So the square root of 4, we got to figure out what number plus 4 is going to equal 4. It'd be at 0. So 0 plus 4 is 4. Don't forget that negative sign in front. Square root of 4 is 2. Don't forget your negative sign. Negative 2 plus 2, that's 0. And so our other point is 0, 0. Well, for Mr. Sika's class, I only care that you have these 3 key points. But if you're in some of the other classes, they may want you to go ahead and figure out what the square root of 9 is. So we simply ask ourselves, what number plus 4 equals 9? Well, that would be a 5. So the square root of 9, square root of 9 is 3. Don't forget your negative sign. And negative 3 plus 2 is negative 1. Once again, we plugged a 5 in for the x. We got a negative 1. So there's your other point. Now we can just draw the curve. Once again, make sure it looks like a curve. If it's a straight line, we will mark it wrong. All right, so we have a few key features down here. The first easiest one I see is the y-intercept. That's where the line touches the y-axis. It touches it right there at 0, 0. Then it's asked for the domain. Now remember the little technique I've told you guys in class. You care about knowing what the smallest x is. So if you take your pencil and you slide it in from the left, eventually we're going to hit the line right here where x is negative 4. So that's my smallest x value. It's less than or equal, because that negative 4 is part of the graph, x. And then we care about coming in from the largest side. Now, if I start sliding my pencil in this way, I'm going to hit an arrow. If I hit an arrow, that means it's going to infinity. Range. We care about the smallest y and the biggest y. So, smallest y first. If I'm coming from the bottom, I'm going to end up hitting this arrow, which means it's letting me know that it's going down to negative infinity. Then I go ahead and I'm sliding my pencil down from the top, and then I hit this point, and its y value is 2. So that is the largest y value. And you have your domain and range. Okay, another square root graph. Once again, square root graphs look like this, or like this. You get one or the other, nothing else for square roots. We want to find our key point by asking the question, what number plus 9 equals 0? Negative 9. The back number is a 2, so I'll mark a 2 for the y. Plot that point. So x is negative 9, y is positive 2. Once again, we want to create the square root of 1 and the square root of 4. So I got to think, what number plus 9 equals 1? That would be a negative 8. So negative 8 plus 9 is 1. The square root of 1 is 1. Now we have a number in front of the square root, which means that 2 is going to get multiplied to that 1. So 2 times 1 is 2, plus 2 is 4. So I have negative 8 plus 4. So I'm going to go ahead and mark that point. I'm going to want to go ahead and do the same thing for the square root of 4. I need to figure out what number plus 9 equals 4. That's going to be negative 5, because 9 take away 5 is 4. The square root of 4 is 2. Once again, you have a 2 in front of the square root. Don't forget to write that. 2 times 2 is 4. Plus 2, that's 6. So, since you plugged in a negative 5, you have negative 5. You have a 6, you have a 6. All right, so at negative 5, we're at positive 6. And once again, this is good enough for Mr. Sika. But if some of the other teachers would like you to go to the square root of 9, then this is what you'll do. You want to ask yourself, what number plus 9 is equal to 0? Sorry, what number plus 9 will equal 9? It will be the number 0. So we get the square root of 9. The square root of 9 is 3. 2 times 3 is 6. 6 plus 2 is 8. So we have 0, 8 as one of our points. So now I'm going to go ahead, draw my curve. And I notice it asked for a y-intercept. Well, I found it. It's right here in orange. Good thing I went to doing the square root of 9. And I know that it's 0, 8. The domain. Once again, we care about the smallest x and the biggest x. So if I take my pencil and I slide it in from the left, I'm going to hit this purple point right here, which means the smallest x is negative 9. So I have negative 9 is less than x, less than or equal to. And then if I come in from the right side, for the largest x, I'm going to hit that black arrow, which means it's going to infinity. Now I'm going to go ahead and do the range. I care about the smallest y value. As I slide my pencil up from the bottom, I'm going to hit this purple point first, and its y value is a 2. So I'll be at 2 is less than or equal to y. And if I slide in from the top, I'm going to hit that arrow, which means it's going to infinity. And I have my largest y. Okay, problem 7. The graph y equals 2 square root x plus 2 minus 2 is shown. It says use the graph to solve each equation. If necessary, estimate your answer to the nearest tenth. Okay, so part A, we have the equation that they've provided, which is what's in black, and then it equals 1.5. This is referring to an equation called y equals 1.5. So therefore, I'm going to make that particular graph. So here is 1.5. So I draw a line, and I can see it intersects right here. And so my answer is 1. That's all there is to it. All right, so part B, doing the same thing. I have it equal negative 1, so it's really y equals negative 1. So I'm going to go where y is negative 1 right here. I'm going to draw a line. I hit this point. Boom. I'm going to have to estimate this time because it's not exactly at negative 2, but it's kind of close. If I had to estimate, I would probably say it's at about negative 1.8. Yes, we'll show some leniency, but you should be in the right, should be pretty close to it. If you're just a little off, I think it'll be okay. Now this one's equal to 0. Well, if it's equal to 0, we're talking right here. Well, if I draw my line, it intersects at this location, and its x value is negative 1. And then part D. All right, we have y equals 3.8. So at 3.8, that's about here-ish. It lines up to about that point, which gives us an answer of 6. And that's how you can solve an equation by graph. Solve and check for extraneous solutions. So these are the really tough ones. This is where you're going to have to do some multiplying, some factoring to figure out what your x's are, and then see which ones are solutions and which one are extraneous. So once again, you should always start off with the making sure that the radical is by itself. It is. There's nothing on the left side of the equal sign except for the radical. So it has an index of a 2, so I'm going to use an exponent of a 2. Now don't forget, when we square the entire quantity of x plus 2. That's going to have this 2 here and this square root cancel out. So we're going to be left with 2x plus 3 equals. Now once again, you can go ahead and use the box off to the side to multiply your x plus 2. And so that's going to be x squared, x times 2x. X times 2 is 2x. 2 times 2 is 4. So you have x squared plus 4x plus 4. Once again, these two are like terms. They create the 4x. But I have been showing you how to do that mentally in your head. and I do recommend that you use it. And once again, we can do that by taking the x and then squaring it. So we have x squared. We take the x and we take the 2 right here. We times it together to get 2x, but then we double it. So 2 times 2x is 4x. And then we take this 2 and then we square it and we get 4. And it's just the same thing as we have over there. Okay, since we have an x squared and an x, that means we want everything on the same side of the equal sign. So we are going to minus the 2x over to where the 4x is. We're going to subtract the 3 over to where the 4 is. These will cancel out because they will equal 0. And then we're going to have x squared plus 2x plus 1 equal to 0 because we want to solve for x. And now we're going to go ahead and factor. So this is where we're going to use our box to do our factoring. So we make our box. We have x squared, 1, 2x. X squared times 1 is 1x squared. So we need to figure out two numbers that multiply to be 1x squared, but will add to be 2x. 1x times 1x will work. So x times x is x squared, x times 1 is 1x, x times 1 is 1x, 1 times 1 is 1. So we know we factored correctly. And then we use our zero product property to solve for x. So we have x plus 1 equals 0, x plus 1 equals 0. You have minus 1 to both sides, so x is equal to negative 1, minus 1 to both sides, so x is equal to negative 1. Well, both of the answers are the same, so they're both going to be solutions, or they're both extraneous. So all we got to do is go back to the original problem that we have up here, and we want to replace all of those x's with a negative 1 to see if it's a solution or not. So 2 times 1 plus 3 equals 1 plus 2. So 2 times 1 is 2. 1 plus 2 is 3 there. This is going to give us 5. So we have the square root of 5 equals 3. The square root of 5 is not 3. That means x equals negative 1 is an extraneous solution. That means both of them are. I only need to write it once, and I should have nothing in the solution part. Number 9, asking us to solve and check for extraneous solutions again. So this time we can notice that the square root is not by itself. There's a minus x next to it, and we need to move it out of the way. So we're going to go ahead and add that x over to where the 5 is. So we're going to have 5x minus 25 equals x minus 5. Don't forget your square root here. Then we're going to get rid of the square root by squaring. Once again, square the quantity, not each individual one. We're going to have 5x minus 25 equals, and then we'll go ahead, we can take the x minus 5 and we can use the box to multiply it, but I'm going to use the shortcut method that I've been showing you in class for the past week or so. So I'm going to take the x and then I'm going to square it to get x squared. I'm going to take the x and the negative 5, I'm going to multiply it together. Then I'm going to double it, so it's negative 10x. Then I'm going to take the 5 and square it to get 25. Now I notice that I have an x squared and an x, so I need to move everything to the same side. So I'm going to minus the 5x over. I'm going to add the 25 over. These are going to cancel out. I'm going to have x squared minus 15x plus 50 equals 0. And now I want to factor that. So I make a box. X squared, 50. All right, so I'm going to go ahead and have 50x squared, negative 15x. So negative 10x, negative 5x would be the combination that works. So x and x makes x squared. X times negative 5 makes negative 5x. X times negative 10 makes negative 10x. So now we've got our factors, and zero product property sets them equal to 0, and you can solve. I would add the 10 over to get x equals 10. I would add the 5 over to get x equals 5. Now we need to check if they're both solutions, both extraneous, or one's a solution, one's an extraneous. All right, so we're going to take the 10, we're going to plug it back into the original. So we have the square root of 5 times 10 minus 25 minus 10 equals -5. Okay, so 5 times 10 is 50. And then 50 take away 25 is 25. The square root of 25 is 5. 5 take away 5 take away 10 is -5. And so -5 equals -5. That makes sense. So I know that x equals 10 is a solution. Need to do the same thing for the 5. So wherever I have an x, I'm going to replace it with a 5. So 5 times 5 is 25. So 25 minus 25 is 0. The square root of 0 is 0. So -5 equals -5. That also works. So x equals 5 is also a solution. Okay, number 10. We're going to be solving and checking for extraneous. So this time, both sides of the equation have radicals, but there's nothing with them. So they're all by themselves, which means we can get rid of them by squaring. So we're going to be left with 2x plus 16 equals -8 minus 2x, and there's no radical sign there. Now I'm just going to solve this equation like you'd solve any equation. I'm going to get x to one side by adding it over to the other x. And I'm going to get 4x plus 16 equals -8. Those are going to cancel. Then I'm going to go ahead and minus the 16 over and get 24. So I have 4x equals -24. I'm going to divide both sides by 4. So x is -6. Now I need to see if it's a solution or not, so I'm going to plug it back in. So 2 times -6 plus 16, -8 minus 2 times -6. So I have -12 plus 16, positive 12. This is square root of 4. This is the square root of 4. They are the same because they're both 2's. And so x equals -6 is a solution. All right, so that shouldn't be down there. All right, so solve the equation. We have the radical by itself, so to get rid of it, we're going to square both sides. And so we're going to get 12.5 squared is 156.25. And the square root is now gone. We're going to go ahead and we're going to minus the 50 to get the x squared by itself. You'll notice there's only an x squared. There's no x in this problem, which means we do not have to factor this one. We then want to get rid of the square. We just want to have the x, so we're going to square root. And we're going to be left with x equals 10.3 when we round. Alrighty, our last problem. This is our review problem, our spiral question. This question will help you earn points back on your last test if you get it right. Plus, it's also points on this test. So it's asking us to simplify the expression, perform the operations, and we should have our answers as rational exponents, which means exponents that are fractions or whole numbers. All right, so step 1 is going to be to rewrite it as rational exponents. So to do that, we're going to start off with rewriting the first part here. We got 2x, and then exponent over index, so we'll have 2 over 3. Then we have 6x. There's a 1 here, 1 over 3, plus 8. x, once again, exponent over index, 7 over 3. And below it, we'll have our 3x squared. From here, we are now going to distribute. So that means this is going to multiply, and then this is going to multiply. So we have 2x 2 over 3 times 6x to the 1/3 plus 2x to the 2 over 3 times 8x to the 7 over 3. Remember, when you multiply, we're going to multiply the 2 and the 6 together. Oops, don't forget your denominator. Okay, 2 times 6 is 12. 2/3 plus 1/3 is 3/3. And then 2 times 8 is 16. And then we're going to add, so 9 over 3. And then we can simplify those fractions. So 3 over 3 is really just a 1. 9 divided by 3 is really 3. And now we want to simplify. So I notice that we have an x here, 3 x's here, and 2 x's here. They all have an x in common. So I can reduce all of them by a single x. Then I'm looking at 12, 16, and 3, trying to find a number that they all share. Sadly, they do not. 12 is made up of, 1 times 12, 2 times 6, 3 times 4. 16 is 1 and 16, 2 and 8, 4 and 4, and 3 is just 1 and 3. They don't all have a single number in common besides 1, so this is as simplified as I can make this problem here.